You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Hello, everyone, and welcome to another episode of The New Stack Makers. I'm your host, Heather Joslin, Editor-in-Chief of The New Stack, and today we're going to talk about observability. It's the start of a planned series on the state of observability, and you may wonder, why observability? Well, because it's never been more important, and it's never been more complicated. We'll dive into why that is and what's ahead in the observability space with our guest, Honeycomb co-founder and CEO, Christine Yen. Hi, Christine.
Hi, Heather. Thanks for having me.
Thank you for joining us. Christine, can you tell us just a little bit about what Honeycomb does?
Absolutely. Honeycomb is an observability platform for teams who manage software that matters. I like to think of it as we help those engineering teams understand what their software is doing and why it's not doing what they expect.
That sounds good, and well suited. You're well suited to help us explore this topic. That's why you're here. So let's start with laying some groundwork here. What are some of the most widely used types of observability, and what are some of the biggest challenges with each?
I think that I don't tend to think about observability in terms of types. But what I imagine you're reaching for is recognizing that the roots of observability lay in logging tools, monitoring tools, and APM tools. Is that where you're going with that?
Yes.
Great. Well, when I think about those three distinct categories, which were how engineering teams for many years figured out what was happening with their software, I really think that each one sort of had or has a fatal flaw that makes them a challenge to use in today's cloud native, much more flexible, much larger scale world. If we look at logging tools, classic logging tools, they are incredibly flexible. Many engineers, myself included, grew up on being able to put whatever you want in a log line. However, log lines and that whole approach are really optimized for humans reading out the data with our eyeballs. And the scale of software that we're operating today, especially in the cloud, simply is no longer human scale. And using log lines as a substrate to answer questions often means that the experience using logging tools to answer questions about your software can be very slow or require a lot of overhead in maintaining indices to try and eke some additional performance out of your logging data. Monitoring tools, in contrast, and again, these are traditional monitoring tools with lots of dashboards and metrics, I really see the fatal flaw there as optimizing for speed over flexibility, almost to the other end of the spectrum from logging tools. There, you can pull up a chart, you can capture and display metrics at impossibly large scale, but it becomes very hard to go, I've got this chart that shows me, let's say latency over time in my system. Now show me this chart, but for this one endpoint. Or show it to me for this one endpoint and this one user agent, something super granular. And the reason that monitoring was so popular then and it is starting to creak now is that in this cloud native world, containers and microservices have been the default way that we deploy software for the last, 10 years now? And a world where you had a small number of app servers that you were watching and an infrastructure that didn't change very much, optimizing for speed over flexibility made a lot of sense. Today, where folks have, instead of one monolithic app on 5 app servers, you might have 50 microservices on top of 500 containers, and then Kubernetes pods that are cycling through those containers and restarting things. You possibly, even without changing anything about your application or your user experience, you have this explosion of complexity in your system that traditional monitoring tools struggle to be flexible enough to support, at least in a cost-effective way. When I think about APM, the last sort of category, the I think APM's fatal flaw was trying to be too magical. Now, I grew up as an engineer using and loving New Relic. And APM tools in the era of Rails apps and convention over configuration and these like very consistent ways of building software meant that those vendors were able to offer magical experiences. You drop their agent in, they'll just slurp up all the right telemetry that you might need to diagnose, the 50 most common problems that a Rails app might run into. You log into the tool and it has all these magical out-of-the-box experiences that tell you you've got these problems. We detected them for you. And that made a lot of sense when there was this consistency in how lots of software is written. But like the monitoring case, we're not in that world anymore. So many engineering teams these days have polyglot storage and microservices where different components are written in different languages and different frameworks. It's increasingly harder for a magical approach to cover the breadth that we see in modern infrastructure. And when I think about the observability needs today and in the future, we can't be making trade-offs between speed and flexibility because we have this complex world that is operating at cloud scale, and tools that we rely on to understand what our software is doing have to be able to slice and dice and surface granular insights about our software at speed and economically enough for it to make sense with the rest of our infra spend.
Yeah. It does seem like speed is very important, especially now because things are so, like you said, things are so distributed, things are much more complex, and if you have a problem, it can cascade, it can much faster. Well, let's talk a little bit. You mentioned the cost. I mean, what do you think are we're hearing a lot about, we're in a period of, a lot of global economic uncertainty. We're starting to hear more from organizations that are trying to contain costs. And part of that conversation is the cost of observability right now. What are some of the things that, in your view, inflate that cost? And where do you see that conversation heading?
I think there are some, there's a lot of factors that contribute to inflating costs. Some are necessary facts of the world, like what I mentioned about how we're architecting software today. It is just now a fact that we're using lots of containers and Kubernetes pods, and there's all of this there are all these additional components in our infrastructure that used to not exist. So that is a driver of complexity. There's also a driver on the practice side, on how engineering teams today talk about their software differently than they may have in the past. When I think about trends in how engineering teams think about their system, I think about DevOps, platform engineering, and SRE. And I think of all of these trends as shaping where engineering teams focus, how they operate, and how they think about delivering a great service. Specifically, I've loved the discussion around SRE and especially, the interest in SLOs, service level objectives, because there's such a clear emphasis with the rise of SRE on the experience of the end user. It's not enough for our infrastructure to be healthy. What matters is whether we are upholding our standards of delivering a great service to those end users. And because the conversation is moving in that direction, it means that attributes that engineering teams are now looking to describe their software in are things that include things like user ID or shopping cart ID, or maybe even the SKU, pretend we're an e-commerce site, the SKU of the item that is being touched by the software or being referenced by the software. There's a human and a process need for an increase in complexity of the language that we use in talking about our software and what's being impacted that is also contributing to an increase in complexity in the data, which contributes to an increase in complexity in the costs. And I hear, as a vendor, I talk to a lot of customers who are trying to adopt SRE practices and SLOs and are suffering because their observability tooling is punishing them from trying to track the things that matter to their business, trying to help them understand the customer impact or business impact of a given engineering change. And as a result, are pulling back on the very data that they need to understand impact. And it hurts to watch because folks are so accustomed to working within the constraints of traditional logging, monitoring, and APM tools that often it takes some conversations to open up their eyes to the idea that modern observability tools are actually built for this level of complexity and expressiveness in telemetry.
When you mention their tools they're punishing them in what way? In that there's just too much data, or there's too many alerts?
Yeah, I alluded to this with when I was talking about monitoring tools. The way that monitoring tools, which again typically optimize for speed over flexibility, the way that they allow for the flexibility, if say an e-commerce site said it's actually really important to be able to break down latency by merchant, not just by, not by HTTP status code, of which there are very few. If a customer says, actually, it's really important to break down by this thing that I have hundreds of, the way that traditional monitoring tools tend to approach that problem is great. Of course, you have 500 customers or 500 merchants on your platform. Of course, we can show you latency by merchant, but we're going to charge you for every one of those. And you start to have this explosion in, oh, well, you want that flexibility? Well, we'll charge you for it. You want custom metrics that capture latency, or whatever metric you're interested in, latency by merchant and SKU and whether there's a sale going or not, well, that'll cost you. And those sorts of, that is an instance where because that traditional approach of how monitoring tools are architected and expect to handle data, that is how they pass those costs onto customers. And as customers try to use these tools that were built for a previous world in this world where they have more complex infrastructures and more complex needs as a human team, they face this exploding cost that frankly is coming from trying to use the previous generation's tools on today's architectures.
Yeah, so that's part of it, the mismatch between the older tools and the more complicated scaled up systems. AI has definitely been AI has been a subplot in a lot of the stories we've reported on in the last couple of years. Where do you see AI presenting challenges for observability tools?
Well, I think I think that there are more opportunities for observability tools than challenges.
Okay, let's talk about that.
Well, when I think about, all right, this is going to be a broad-ranging answer, so I'll try to bring you through it in a structured way. I think generative AI has maybe like a threefold impact on observability tooling. There is the obvious, every SaaS wants to use generative AI to improve our own experience for our users. And I'm really excited for Honeycomb. We've got some cool stuff brewing where we're, of course, using some of the latest technologies, latest models to make it easier for folks to understand how to use Honeycomb, to approximate some of that magic that the traditional APM tools had, but being able to really learn and adapt to a given customer's data. In May of 2023, Honeycomb was one of the first companies to release in production a natural language query interface. And so instead of using our query builder to construct queries over their data, users could just come in and type in, can you show me errors that users are encountering when they're trying to log in? We're going to translate that. So I think that piece, generative AI has as much a role for observability tools as any SaaS to just make the experience better. But given that we serve builders of software, the second side of how generative AI can plays into the observability story is that so many software engineering teams out there right now are being told, go put some generative AI into your product. Use this black box, figure out how to make it work. And I would love to be able to say that generative AI APIs are as stable as the ones we know and love. Twilio, Stripe. Oh, here's this really predictable input, output, standard expected behavior. But that's not how users are using generative AI. That's not how this black box in particular works with our systems. Pulling generative AI capabilities into a product mean you're introducing non-deterministic behavior. Each of these API calls is extremely parameterized. So there's so many different factors that go into different behaviors. And I think that the need for observability tooling that is flexible and fast becomes more and more important as these software engineering teams are trying to figure out, often live, what's happening with this generative AI feature. Why is it not behaving? Why is it hallucinating? How can we get a handle on why it's hallucinating and how to guide it back into reality? So that continues to be really exciting. The last piece is a little bit more of a challenge, but I think it's a little bit more of a challenge for the broader engineering industry, where we are hearing more and more teams are going all in on Copilot. Entire software engineering teams are buying licenses for their teams to be able to have AI-assisted code be out there in the wild. And I think it is very exciting to have tools to help with code authorship. And we know that when, we started this conversation talking about how observability is for when your software doesn't do what you expect. And we believe that as these AI code generation tools are used more, there's going to be more code out there in the wild that we don't fully have, we don't maybe understand quite as well, or starts doing things that we didn't expect. And I think I look forward to the era which is coming of AI code ownership. What does it look like to own the code that your generative AI tool spat out? And I think that will be, we're all going to have to navigate it together. And observability tools are necessarily going to play a part in understanding, okay, this code is out there. What is it doing? And how do we rein it back in?
Yeah. Yeah, you hear I've read some estimates of like how much code right now is AI generated or how much is going to be in the near future, and it's pretty dazzling how fast things are moving.
Yeah. Some of the best analogies I've heard from folks are that, Copilot is like having a really enthusiastic intern. We've all been in situations where interns have pushed code and maybe something's gone wonky, and imagining, legions of interns, no knock on interns, but, we all have to start somewhere. But imagining legions of interns now pushing code into the wild, I think we're going to be in for an interesting time.
Yeah, absolutely. Wanted to touch on another big topic in observability, OpenTelemetry. It's kind of poised to have potentially this can be a big year for adoption. I know that Honeycomb uses OpenTelemetry in its solutions. I know that their profiling signals are slated to be in general availability later this year. What are some things you'd like to see on the OTel roadmap?
Yeah. Honeycomb is huge in OpenTelemetry. We are huge supporters of OTel. We have someone on the governance board right now, our maintainers and contributors on several projects within OTel. So we love OTel. The two things I think I'm the most excited about coming to fruition, first, stabilizing semantic conventions. There's so much power to OpenTelemetry being the open standard and the standard that the industry aligns on for emitting telemetry. And semantic conventions means that not only is the shape and the signals and the signal types becoming more consistent, the more folks start to adopt conventions in how they name things, the smarter that tools can be, OpenTelemetry compatible tools can be in surfacing and sort of deciphering intent and connections from telemetry about the software that telemetry is describing. So naming, we know, one of the classic hard problems in software, but a huge amount of appreciation to the folks at OTel for working within OTel to standardize that and push that out and solve that at a global level. The second thing that I'm really keeping an eye on is the OpenTelemetry control plane. I think that a thing that we are all seeing that I'm actually quite excited about is that with the rise of OpenTelemetry, sort of converging with folks thinking about cost, more and more engineering teams are seeing their telemetry as something that they own. In the past, telemetry was something that a vendor helped you collect and then a vendor consumed, and it was sort of all part of that vendor experience. And I don't think that's the way it should be. I think that the telemetry coming out of your software is something that a team should take ownership over. And I think there are some really exciting things happening in the sort of pipeline, agent, collector world that will make it a lot better experience for folks to take that ownership over to the telemetry, have that control, and get the best experience that they can out of this huge coalition of vendors who are all compatible with OTel. So I couldn't be more excited about what OTel is bringing in 25, and Honeycomb is going to remain a staunch and excited supporter of the OTel movement.
That's great. One last question. Are there any other trends or developments you see emerging in the observability space that you're watching closely?
There has been a maybe predictable explosion in the number of AI SRE or AI DevOps engineer companies. And it is interesting because on one hand, it trying to make sense of telemetry and trying to understand, trying to decipher what some paper trail is telling you about your software and how to resolve it. Like, that is one of the just hard problems of building reliable software today. So absolutely understandable that there's a lot of smart founders and VC dollars chasing that problem. And from our experience, sort of being in this world for a little bit now, there's a lot of context that doesn't yet exist in the telemetry itself. There's a lot of context that a human brings to distinguish between a DDoS and a load test that might look the same in telemetry. Our approach has always been to focus on building mecha suits instead of robots. How can we amplify the context and the judgment of the humans on a team, point them in the right direction, allow the humans to do what the humans are great at, which is, that looks weird, and allow the machines to do what the machines are good at, which is crunch through a ton of data and offer you options. I think this will be really interesting to keep an eye on. We're certainly thinking through how we can leverage AI to be a little bit more of that teammate, but I think there's going to be a huge variety of approaches over the next few years that we're all going to be experimenting with together.
Sounds good. And that sounds like a good place to wrap up. I want to thank today's guest, Christine Yen from Honeycomb. Thanks, Christine.
Thank you, Heather, so much for having me. This has
been
fun.
A pleasure. It's been a pleasure. And I'd like to thank all of you for joining us for today's conversation. This has been Heather Joslin of the New Stack for the New Stack Makers, and we'll see you next time.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.